Hello students, in the previous session we have studied the basic terms related to the arithmetic progression and how to find the nth term of an AP. Now we'll solve some more examples based on the concept. Question is, find how many 3-digit numbers are divisible by 5. So for this one we have to find firstly the 3-digit numbers. So the smallest 3-digit number, as we know, it is 100, and here we want a 3-digit natural number. So the next natural number to 100 is 101, next to it is 102, up to now we need all the 3-digit natural numbers. So the largest 3-digit natural number is 999, because thereafter we get a 4-digit natural number, that is 1000. So this is the range of the 3-digit natural numbers. Now out of which we have to find those numbers which are divisible by 5. So out of these, 100 is the first number which is divisible by 5. Then after that we have 105, which is again divisible by 5. Then next number is 110, up to the last number, last 3-digit number which is divisible by 5 is 995. So these are the numbers. 100 is the first number and 995 is the last number which are divisible by 5 and which are 3-digit number. And we have to find how many 3-digit natural numbers are there which are divisible by 5. So we have to count these numbers 100 to 995, and here we are going to use the formula for the nth term of an AP. So we know the nth term of an AP is denoted by Tn is equal to A plus n minus 1 into D, where A is the first term and D is the common difference. Now in the above AP, as these terms, they have a constant common difference between consecutive terms, that's why this is an AP. We can use this formula to find how many numbers are there in between 100 and 995. So here the first term, which is denoted by A, and in the given AP the first term is 100, so A is 100, and the common difference, now as we can count the common difference between 100 and 105 or 105 and 110 is 5, so that's why the common difference is 5. So we have Tn is equal to A, that is the first term is 100, plus n minus 1 into D. D is the common difference, that is 5. Now the last term is 995 and we have to find the number of the 995 in the given AP. So that's why instead of Tn we will take 995 is equal to 100 plus, now we'll simplify this 5 into n, that is 5n, minus 5 into 1, that's 5. So that is equal to 995 is equal to 100 minus 5, we'll get 95 plus 5n. Now if you transfer 95 to the left hand side, we will get 995 minus 95 is equal to 5n. So that is 900 is equal to 5n. We have to find the value of n, that's why transfer 5 to the left hand side again, so as to get 900 divided by 5 is equal to n. So if we divide by 5, we'll get 5 ones are 5, 4 is remaining, 5 8s are 40 and 0. So 180 is equal to n, that is n is equal to 180. That means in a given AP, that is 100, 105, 110 up to 995, here the last term 995 is the 180th term in this AP. That's why in all there are 180 terms which are divisible by 5. The next problem is in an AP, 17th term is 7 more than its 10th term. Find the common difference. So here the relation between 17th term and 10th term are given. We have to use that. So first of all we have to find those terms. So we have the general form of nth term of an AP, that is Tn is equal to a plus n minus 1 into d, where a is the first term and d is the common difference. So here the 17th term we have to find. So if we replace n by 17, we will get T17 is equal to a plus n minus 1, that is 17 minus 1 again, into d. So that is equal to a plus 17 minus 1, that's 16d, that is T17. Similarly, we have to find the 10th term. So if we replace in the general formula Tn by T10, it will be the 10th term of that AP. So again the same formula is there, a plus n minus 1 into d, that is a plus, instead of n now we should take 10 minus 1 into d, that is equal to a plus 10 minus 1, that's 9d, is equal to T10. So these are the terms T17 and T10. So there is a relation given that in an AP the 17th term is 7 more than its 10th term. So we have to use this one. So 17th term we denoted by T17, that is equal to, if we have to equate it with the 10th term, we should add 7 to T10, that is T10 plus 7, as 17th term is 7 more than 10th term. So if we have to equate these two, we should add 7 to the 10th term, that is T10, so as to get these two equal. Now we have T17 as a plus 16d, so we should replace that. A plus 16d is equal to T10 is a plus 9d, a plus 9d plus 7 as it is. Now we have to solve this equation to find the common difference d. So on the both the sides a will get cancelled. So if we have 16d, if we transfer 9d to the left hand side, it will become minus 9d is equal to 7 on the right hand side. So 16d minus 9d, it is 7d is equal to 7. We have to find the value of d, that's why we will transfer 7 to the right hand side. So that will be in the denominator 7 by 7. If we divide, we will get 1 divided by 1, that is d is equal to 1 divided by 1, that is 1. So in this given AP, the common difference, that is d, is 1. The next point is sum of first n terms of an arithmetic progression. Before this we have studied how to find the nth term of given AP. Now our point is to find sum of the first n terms of an arithmetic progression. So let us consider one arithmetic progression. Let a plus d, a plus 2d, a plus 3d up to a plus n minus 1 into d be an arithmetic progression. Now if we have to find sum of all these terms, we have to find one formula, and for that we denote the sum of all of these terms by a letter Sn. So Sn is equal to, we have to add all these terms, that is a plus d plus a plus 2d plus up to a plus n minus 2 into d plus a plus n minus 1 into d. Now if we write these terms in reverse order, we will have Sn is equal to, here we will write the last term firstly, that is a plus n minus 1 into d, then the second last is a plus n minus 2 into d plus up to The second term is a plus d plus a. Now here if we add these two equations, we'll get, on adding these two, we'll get Sn plus Sn, that is 2Sn, that is we have added the left hand side into the left hand side. Now it's turn to add right hand sides. So the first term in the first equation is a, and first term in the second equation is a plus n minus 1 into d. So we'll add these two. In rectangle bracket we'll have a, that is the first term here, plus a plus n minus 1 into d. So this is the addition of first two terms in two equations. Now second two terms are plus, in rectangle bracket we'll have a plus d plus, here again we have a plus n minus 2 into d plus, and so on. The second last term is a plus n minus 2 into d plus a plus d plus, and the last term is a plus n minus 1 into d plus a. So that is equal to 2Sn is equal to a plus a, that's 2a, plus n minus 1 into d, plus into the second bracket we have a plus a again 2a, plus n minus 2 into d plus d, that will be n minus 1 into d, plus up to the second last term is, again here we have a plus a, that is 2a, plus n minus 2 into d plus d, that is n minus 1 into d, plus, and the last term is also a plus a, that is 2a plus n minus 1 into d. So on the right hand side we have 2a plus n minus 1 into d, 2a plus n minus 1 into d, n times. We have added this rectangle bracket n times, that's why we can write it as n into bracket, that is we can write it as n into bracket 2a plus n minus 1 into d, and the left hand side is 2Sn. We have to find the formula for Sn, that is sum of all terms in an AP. So we'll transfer 2 to the right hand side, that is to get n divided by 2 into bracket 2a plus n minus 1 into d. So this is the formula by which we can find the sum of n terms in an given AP, where a is the first term and d is the common difference. So if we are given the first term and the common difference, by using this formula we can find sum of all terms in that AP. Now we'll solve some examples based on this concept, that is sum of n terms of an arithmetic progression. The first question is, find the sum of first 123 even natural numbers. So to find first 123 even natural numbers, first we should write the natural numbers. So the natural numbers are 1, 2, 3 and so on. Now from these natural numbers we want first 123 even natural numbers. So the first even natural number is 2, then 4, 6, 8 up to 123 terms. So here even natural numbers are 2, 4, 6 and so on. So we need 123, such 123 terms, and we have to find the addition of those terms. Now as we can see here, the difference between any consecutive two terms is 2. That's why this is an AP. It has a first term, that is first term A is 2 here. The common difference D is also 2. Now from this we can find the sum of all these terms by using the formula. So we have the formula Sn is equal to n divided by 2 into bracket 2a plus n minus 1 into d. So here we need the sum of first 123 terms. That's why instead of n we should take 123 divided by 2 into bracket 2a, that is 2 into a is 2, will replace that, plus n minus 1 into d, that is 123 minus 1 into d is 2 again, that is equal to 123 divided by 2 into bracket 2 into 2, that's 4, plus 123 minus 1, that is 122 into 2. So we have 123 divided by 2 into bracket 4 plus 122 into 2, that is 244, is equal to 123 divided by 2 into 4 plus 244 is 248. If we simplify, we'll get 2 1s are 2, 2 2s are 4, and 2 4s are 8. So that is equal to 123 into 124 is equal to Sn. So Sn is equal to, if we multiply these two, 15,252. So this is the sum of first 123 even natural numbers. There is another formula by which we can find the sum of first n terms in an arithmetic progression. So as we know, this is the formula, Sn is equal to n by 2 into bracket 2a plus n minus 1 into d, by which we can find the sum of first n terms in an AP. So here a is the first term and d is the common difference. So in any problem, if common difference and the first term are given, by using this formula we can find the sum of first n terms. But instead that only first term and last term are given for an AP, from that also we can find the sum of all terms in an AP. So for that we need another formula which can be derived from this basic formula, that is, we can also write it as Sn is equal to n by 2 into bracket, we can split 2a into a plus n minus 1 into d as it is. So we have splitted here 2a into a plus a, that is equal to n by 2 into bracket, we should write here a plus, now instead of this, a plus n minus 1 into d, which is the general formula for Tn, that is nth term of an AP. So n by 2 into bracket, now a is the first term which is also denoted by T1 plus Tn, that is the nth term. So this is the formula by which we can find the sum of first n terms, where the first term and the nth term are given. So for this formula we need not the first term and the common difference. Instead, if we are given the first term and the last term, by using this formula we can find the sum of first n terms of an AP.